Okay, so we have this question right here. It says two identical charged particles were placed in a vacuum 0.02 meters apart. The charge on each particle was positive 8 times 10 raised to power minus 6 coulombs. And which of the following gives the magnitude of the force in newtons on each particle? Now, first of all, what we will do is we will first identify what values we have been given. Okay, we will mark it down. So we have been given two identical charged particles value, which is positive 8 times 10 raised to power minus 6 coulombs. And then we have been given the distance they are placed apart. Okay, so basically these are the two charged particles in a vacuum and they're placed apart by 0.02 meters. Okay, now we need to find the force value on each of the particles. Okay, so in this situation, we will be using the Coulomb's law formula, right? As it helps us find the force on each of these particles, or basically these two particles, okay? Now, if you see your formula sheet, right, there are basically three formulas under the Coulomb's law section. We will be using the first one. The other two we are not going to use, as it helps us find some other value in some other situation. Okay, in this situation we need F is equals to Q1. Let me write it down. F is equals to Q1 times Q2 by 4 times pi times permittivity of free space times r square. Okay, and a quick tip, sometimes people don't know how to find some questions value. So as I said in the starting, right, what you can do is you can mark down what values you have been given, and then you can search your formula sheet and find out where those values fit. Sometimes it can help you very well, and then you can find your answers, especially for the MCQs, right? Because sometimes you're not required to find the answer. Instead, you need to find the format of the answer, right? So this is a quick tip. If it helps you, good. If it doesn't, just understand how we are doing this question. Okay, so we will be using this Coulomb's law formula, and some people might think, hey, you do not have the permittivity of free space value. What to do here? In your exam, or basically in your formula sheet, you have been given the Coulomb's law constant value, right, which replaces this whole thing, right? How it does it? So basically the symbol for it is K is equals to, and it replaces 1 by 4 pi permittivity of space with the value of 8.99 times 10 raised to power, basically it's I think 9, yeah, and Newton meter square by Coulomb square. Okay, so this is the value, and then we will be replacing it here, so it will become F is equals to Q1 times Q2 by R square, and let me extend the line, times K. Okay, the Coulomb's law constant. Okay, now we will input the values, which will be F is equals to Q1, basically the charge particle value, which is 8.0 times 10 raised to power minus 6. Okay, you can write it again as well, or you can write the square of it. You can make square of it, it's up to you. Okay, and then you can multiply it by the Coulomb's law constant value, which is 8.99 times 10 raised to power 9. Okay, and then you can divide it by the r value, which is basically the distance they were placed apart. Okay, which is 0.02, and square it. Okay, so now let's check our options. Okay, they don't require the full calculated answer, they require the format. Okay, so on option A we can see that it missed out the square over here, so this is incorrect. We can see from option B that it follows our answer format, so it's correct. Basically the switching can happen, you can write it here or here, it doesn't matter. Okay, and then you have option number C. Let's take other options as well, just to be safe. Okay, so option C is incorrect as it doesn't have the square here, and option number D is also incorrect as it does not have a square here. Okay, so our final answer is B. Okay, follow for more.